Welcome to Module 2, where we dive into the world of functions. We'll explore how to define and call functions, handle parameters, and work with return values. This module is divided into 3 key lessons to help you master these essential programming concepts. Let's get started. Here is our roadmap for this module. We begin with function basics, covering creation, parameters, and return values. Next, we examine function scope, including local and global variables. Finally, we look at lambda functions, their syntax, and practical applications with map and filter functions. Let's dive into Lesson 1, Function Basics. We'll learn how to package your code into reusable blocks, define functions using the def keyword, pass input through parameters, and get output back with the return statement. Mastering these fundamentals is the key to writing efficient code. By the end of this lesson, you will be able to explain the purpose of functions, create them using the def keyword, manage parameters, handle return values, use default parameters, and implement best practices for clean, reusable code. A function is simply a reusable block of code that performs a specific task. Think of it like a machine. You provide input, it performs a process, and it delivers an output. This approach improves your code's organization, reusability, readability, and overall maintainability. Why are functions so important? Without them, you end up repeating the same code, which is prone to errors and difficult to maintain. With functions, you write the logic once and call it whenever needed, keeping your codebase clean, concise, and easy to update. To create a function in Python, use the def keyword followed by a name, parentheses, and a colon. The indented code below it is the function body. Remember, defining a function doesn't execute it. You must call it by writing its name, followed by empty parentheses. Functions become much more powerful when they accept inputs, known as parameters. By defining a parameter within the parentheses, you allow the function to use that value inside its body. This lets the same function produce different results based on the input provided. You can pass multiple parameters into a function by separating them with commas. Keep in mind that order matters. The first value you pass goes to the first parameter, and the second value goes to the second parameter. This allows your functions to handle more complex logic. Sometimes, rather than just printing, you want a function to send a result back. Use the return keyword for this. The return value can be stored in a variable, printed later, or used in further calculations, a practice common in professional software development. It's important to understand the difference between print and return. Print just shows a value on the screen, while return allows the program to actually work with that data. A good rule of thumb is to use print to show a value, but use return to reuse it. Parameters can also have default values. If you provide a default value in the function definition, Python will use that value automatically if you don't supply an argument when calling the function. This adds a great deal of flexibility to your code. Let's see this in a real-world scenario. Here, we calculate a total price by combining a base price and a tax rate. By using a function, we make our checkout logic simple, testable, and reusable throughout our program. To write high-quality code, follow these best practices. Ensure each function performs only one clear task, choose descriptive names that explain the function's purpose, and keep your function small. This makes your code significantly easier to read and debug as it grows. Ready to practice? Here are 4 exercises to reinforce these concepts. Try writing functions to print a message, greet a user by name, perform addition, and calculate the area of a rectangle. Pause this video and give them a try. Here's a mini challenge to test your skills. Write a function called calculate_discount that takes a price and a discount percent, then returns the final price. For instance, a price of 100 with a 20% discount should return 80. Use the hint to guide your math. Let's recap Lesson 1. We've covered defining functions, passing parameters, returning values, using default parameters, and the importance of writing clean, reusable code. You are now ready to move on to understanding where these variables live. Welcome to Lesson 2, where we focus on function scope. Every variable you define has a scope, which determines where it can be accessed within your program. We will distinguish between local and global variables and how they interact. Scope is the rule that determines the visibility of your variables. Think of it like rooms in a house. A variable defined inside a function is like an item in a locked room, only accessible there, while a global variable is like an item left in the hallway, accessible to everyone. Local scope is limited to the function in which a variable is defined. As you can see in the example, if you try to print a variable outside the function where it was created, Python will raise a name error because the variable simply does not exist outside that local scope. Global variables are defined outside of all functions, making them accessible throughout your entire program. In this example, the function can read the quote message variable directly because it resides in the global scope. It is entirely possible to use the same name for a local and a global variable. Python keeps them separate. Modifying the local variable inside a function will not affect the global variable with the same name, as they belong to different scopes. If you specifically need to modify a global variable inside a function, you must use the global keyword. Without it, attempting to modify a global variable will result in an unbound local error, as Python will assume you are trying to create a new local variable. While the global keyword exists, professional practice is to avoid modifying global variables inside functions. Instead, pass the data in as an argument and return the new value. This keeps your code cleaner, easier to debug, and more predictable. To visualize scope, imagine each function as a private box. Variables inside cannot be touched from outside. A common mistake is trying to update a global variable without the global keyword. Always remember to pass your data and return the results for safer code. It is time to practice. Try these 3 exercises to master scope. Predict the output of the provided snippet, fix the error in the second example, and write a function that adds 5 to a number and returns the new value. You've successfully completed the second lesson on scope. By now, you should understand how to differentiate between local and global variables and the best practices for handling them. You're ready to proceed to the next topic. Welcome to Lesson 3, Lambda functions. These are compact, anonymous functions used for simple operations. They are perfect when you need a function for a single, short-lived task, and don't want to define a formal function with a name. A lambda function is defined with the lambda keyword, followed by arguments, a colon, and an expression. It takes arguments and returns the result of the expression. It is a powerful, concise alternative to writing a full function definition for simple operations. Here are some basic examples of using lambdas to square a number, multiply 2 values, or check if a number is even. Each operation is performed cleanly in one line, demonstrating the efficiency of lambda functions for simple tasks. You can call a lambda function immediately, even without naming it. By wrapping the lambda in parentheses and adding the arguments in a second set of parentheses, you can execute it on the spot. Additionally, lambdas can accept multiple arguments just like standard functions, simply by separating them with commas. Lambdas are powerful when used with map and filter. Map applies a function to every item in a collection, while filter keeps only those that return true. In this video, we see how map squares a list of numbers and how filter isolates the even values from a list. Sorting is another common use case for lambdas. By providing a lambda as a key, you can tell Python exactly which part of your data to sort by. Here, we sort a list of student records based on the second item in each pair, their grade, rather than their name. How do lambdas compare to regular functions? While both perform tasks, a lambda is small, anonymous, and restricted to a single expression. Use a regular def function for complex or reusable logic, and reserve lambdas for tiny single-use operations. Use a lambda when the logic is simple and used only once. They are frequently found in data processing with libraries like pandas and numpy, as well as in machine learning pipelines. Remember, if the logic is complex, it is always better to use a named function. Time for some practice. Try these 3 exercises. Create a lambda that adds 10 to a number. Use map with a lambda to double a list, and use filter to extract numbers greater than 5. Give these a try to solidify your understanding. Let's recap this lesson. We've explored what lambda functions are, how to use them with map, filter, and sort, and when they are the best tool for the job. Lambdas are excellent for quick, clean data transformations in your code. Congratulations! You have finished Module 2 on functions. You've learned how to define and call functions, manage scope, and write compact lambda functions. These are the fundamental building blocks of every Python program. Great work, and we look forward to seeing you in the next module.